Hi, folks. Welcome to week 4. This week, we're starting on physics, which means that some of the labs are going to have more of a hands-on feel to them. So we have 3 new labs this week, but before I tell you about those, I do want to remind you that you always have the option of doing one of the labs from a previous week that you haven't already done. So if any of those week 3 labs look appealing and that you haven't done yet, go ahead and give those a try, one of those a try if you'd like. But this week, as I say, we have 3 new labs. The first of those is called Falling Bodies. And this lab really has 2 different agendas to it. First of all, I do want to give you a chance to experiment with gravity. Try dropping things off of buildings, seeing what it's like, and timing those measurements. But I also want you to be grappling with the whole idea of uncertainty and uncertainty in measurement. All measurements have an uncertainty. We can never measure things to infinite precision. And with this experiment, some of your measurements are going to have a big uncertainty. You're going to be finding it really hard to actually get good timing measurements. And that's okay. We designed it that way. So I want you to be thinking about that, thinking about what causes it, how big that effect is, and maybe even some of the ways to try to mitigate that. So the idea with falling bodies is that you're going to take something that you can drop, like a tennis ball or something else that you don't mind dropping from a height, and drop it from several times from several different locations. Each time measuring how high you're dropping from. The higher you can go, the better. So if you can get up to a second or third story and drop things from there, that's even better still. And you want to time how long it takes that ball to drop. And so you're going to do this, as I say, several times from several different heights, and then use all of that to measure how much acceleration due to gravity there is. In other words, how much the things speed up as they're falling. This one also has an exploration experiment, and that is the second half. And there's a few different options there. The most popular one, though, is to try dropping other things and make some predictions about how you expect the results to be different. Um, so, so since this is a fairly involved lab, I'm actually giving you 2 weeks to do this experiment. So if you like, you can turn in the skill building part this week, and then turn in the other part, the exploration experiment, next week. Or if you want to just save it all and turn it all in next week, you can do that. But let me know that's what you're doing, so I don't get worried when I don't see your assignment come in this week. The other hands-on lab that we're going to be doing this week, or that you have the option for, is called Do Your Own Experiment. And with this lab, the goal is for you to come up with the experiment, although I give you lots of good starting points. I give you, in fact, several different links to different online sites that have videos or descriptions of different kinds of physics-related demonstrations. And what I want you to do is pick one of those and make a lab out of it. So by making a lab, that means not just repeat the demo the way they do it. I want you to come up with a hypothesis of what you expect. I want you to be able to describe what you're doing. But I also want you to be in order to test your hypothesis, I want you to try going beyond what they simply describe in the demos that are given. So I want you to try changing up the conditions. Maybe make it a little bit try changing the temperatures or the speeds or the weights, or depending on the experiment, there are different ones, they all do different things. But I want you to see the way to really understand how something works is to see, well, what happens if we play with the conditions? What happens if we change it? And what do we expect? How do we expect that to change the results? And then I want you to record your results and This is a good one if you can take pictures, do videos frequently. That's a really good way to record your results. Um, but even before you do all of that, I want you to send me a proposal. That means I want you to send me a little summary of what experiment you want to do, how you're going to vary it, how you're going to change things up a little, um, what your uh, and how what you're doing relates to the things we're talking about in the course. Okay, now we're talking about a lot of different things in this course, right? This week we've been doing lots with motion and energy and the gravity. So you got a lot of options here. But I do want you to be able to make that connection between the experiment you're doing and the other things we're doing in the course here. So so make sure you send that proposal to me before you do the experiment. That's important because I want to be able to give you feedback on it. So you can actually send that to me by email or through the inbox so that I can see see what you're doing and even give you some feedback and maybe let you know about ways that you can things you might have to watch for, safety concerns, or just ways that you can to make it easier and more effective to test what you're trying to test with it. Your for the for presenting this, you've actually got a few different options this time around. So you can certainly do a traditional kind of write-up with all the different sections the way you normally would, but you can also do a presentation, a video presentation, or a slideshow, or something like that, if that's the way you'd prefer to do it. So you've got some flexibility in terms of how you present your results, and that's what I want you to give that a try. The third lab option for this week is called the Mass of Jupiter, and this is one that really recreates a classic astronomy experiment where we look at the moons of Jupiter and how they orbit around the planet and use that to figure out the mass of Jupiter. And so we'll give you the data in this case. You'll get a nice little chart that shows how the moons are moving and how fast and how big their orbits are. And then you're going to use that to to calculate how much mass Jupiter has. And that's the key you want to keep in mind when you're doing that experiment. You're not calculating the masses of the moons. That doesn't come into it at all. What you're calculating is how much Jupiter is making those moons go around the planet. And so that's what you're going to be finding. And then you can, and since you're going to be doing this for 4 different moons, you're going to be able to get 4 different experiments to measure the mass of Jupiter. And then you can see how they compare with each other and see if they're consistent or not. So that's so those are the lab options for this week. Remember, a couple of these do have tutorials. The both falling bodies and mass of Jupiter have built-in tutorials, so make sure you view those. And if you have any questions about them, please let me know. Okay, answering your questions is a big part of my job, so I'm always happy to do that. So definitely don't hesitate. Send me your questions, and I'll try to get back to you as soon as I can on them. All right. See you next week.